Hello everyone. Today we'll start with chemical energetics. Before to start this chemical energetics, you should know about few definitions, and some of the definitions you have learned in your AS and some of the definitions will be new for you. Very first definition, that is standard enthalpy change of formation. This is standard enthalpy change delta H. F enthalpy change of formation, and symbol for this standard enthalpy change of formation is delta H, and standard sign F stand for formation. This is the enthalpy change of formation. And what is this standard enthalpy change of formation? It is the enthalpy change, whether it is endothermic or exothermic, both are the possibilities. Enthalpy change when one mole of a compound is formed from its elements, from its constituent elements or from its elements under standard state conditions. That is known as enthalpy change of formation. Again, I repeat, understand this definition: standard enthalpy change of formation. Standard enthalpy change of formation, it is the enthalpy change when one mole of a compound. It means on the product side, it should be 1 mole. And on the other side, number of moles, they can be different. So this is, for example, NaCl, enthalpy change of formation for NaCl. There are two different elements. Number one is sodium and the second is chlorine. Now, state symbol and standard condition for sodium, it's a metal, and all the metals, they are solid. And chlorine, it's a diatomic molecule. This is Cl2 gas. They will react together to form NaCl. And this is not a balanced chemical equation. How we can make it balanced? Make sure on the product side it should be 1. You cannot change this number on the product side. But on the reactant side, to make it balanced, we need 1 chlorine atom, so we'll multiply with 1/2 Cl2. This is the enthalpy change of formation equation for sodium chloride. And now, which type of process occur in this enthalpy change of formation? On the reactant side, the sodium solid, and bonding for sodium solid, it's metallic bonding. Chlorine, it's a diatomic molecule. So bond breaking on the reactant side. So this is bond breaking on the reactant side, and bond breaking is always endothermic. And on the product side, there is bond formation. If there is bond formation on the product side, bond formation is exothermic. So both the process, they are possible in endothermic and exothermic. So this is a reason this reaction, enthalpy change of formation, can be endothermic or it can be exothermic. Both are the possibilities for this enthalpy change of formation. Another example for enthalpy change of formation is MgO, magnesium oxide. Again, if you see, there is two different elements. Number one is magnesium and second is oxygen. And state symbol for magnesium, it's a metal and it's going to be solid. And for oxygen, and you are learning from the beginning of your O levels, O2 oxygen exists as diatomic and it's a gas. They will react together to form MgO. On the product side, it should be 1 mole. And how we can convert this 1/2 O2? If we multiply with 1/2 O2 to make it single oxygen. So this is known as enthalpy change of formation for MgO. Another example is calcium chloride, CaCl2. How we can write enthalpy change of formation for this calcium chloride? We'll write calcium, it's metallic bonding, solid, and chlorine, this is a diatomic gas. They will react together to form calcium chloride, and this is a balanced chemical equation. And enthalpy change of formation for NaN3, this is NaN3, this is known as sodium azide. How we can write enthalpy change of formation equation for this? First of all, we will identify elements, sodium and nitrogen. This is sodium, and it has metallic bonding, solid, and nitrogen. Nitrogen exists as diatomic molecule. And how we can make this N2 into 3? We'll multiply by 3 by 2 to make it NaN3. This is sodium azide. Now, this was about enthalpy change of formation equations and definition of enthalpy change of formation. So what is enthalpy change of formation? It is the enthalpy change when 1 mole of a compound is formed from its elements under standard state conditions. Second definition, that is enthalpy change or standard enthalpy change of atomization. This is standard enthalpy change of atomization. In standard enthalpy change of atomization, symbol for this is delta H, standard, and atom. This is atom. And you are learning from the beginning of your grade 9 atomic structure. If you see atom, all the atoms, they exist in single state. Like noble gases, they exist in single state. That state is atomic state. But if you see for halogens, are they in atomic state? The answer is no. They exist in molecular state. They exist as diatomic molecule. But if you see oxygen, nitrogen, and all the elements, they exist as either diatomic molecule or they exist in giant metallic lattice. Metals, they exist as giant metallic lattice. And for noble gases, they exist in atomic state. So what is mean by atomic? This atomic mean there must be a gas and it should be in single atom atomic state, that is known as atom. So how we can define this enthalpy change of atomization? This enthalpy change of atomization is enthalpy change when 1 mole of gaseous atom is formed. Gaseous atom is formed from its element, that is known as enthalpy change of atomization. And if there is standard, so we'll write under standard state conditions. So what are the standard state conditions? They are 25 degrees C temperature and 1 atmospheric pressure. These are the standard conditions. And if you see for standard enthalpy change of atomization for sodium, sodium exists as solid. There is giant metallic lattice. There is metallic bonding. All the metals, they exist as giant metallic lattice. Sodium solid, it will turn into gas. Now there is a breakdown of giant metallic lattice. So there is a breakdown of a lattice, breakdown of lattice that is always endothermic. Now if you see for copper, it's a solid and we need to heat up to convert this copper solid into gas. We will break this giant metallic lattice of copper. Again, this is positive. And for magnesium, if you see for magnesium, it's a solid, and if you break this magnesium solid, it will turn into magnesium gas. This was about enthalpy change of atomization for metals, and enthalpy change of atomization is always endothermic. But here, this was enthalpy change of atomization for metals. But if there is non-metal, like halogens, all halogens, they exist as diatomic molecule. This is X2 gas. We need to break down this X, and by providing it their bond energy, we'll get 2 atoms of X if we provide their bond energy. Bond energy, you know very well what is bond energy. Bond energy is energy required to break a specific covalent bond under in their gaseous state, that is known as bond energy. And if you break this X2, we'll get there is 2X atom, but we need 1X. To make it balance, we will multiply by 1 by 2 on the reactant side. For example, this is chlorine. To break this 1 chlorine, bond energy for chlorine is, this is the bond energy, 2, 4, 2, it's a bond energy. But for 1 atom, we need half bond energy of this. So delta H atomization of this chlorine is going to be 1 to 1, positive 1 to 1. This is bond energy for non-metals and for diatomic. Here you can note down this point, delta H atomization for diatomic molecule. For diatomic molecule is half of the bond energy. Another example for this, oxygen. If you see oxygen, it's a diatomic molecule, and we need one oxygen for this delta H atomization. There will be O gas. To make right delta H atomization, so we'll multiply by 496, multiply by 1 by 2 or divided by 2. This is going to be delta H atomization for oxygen. And in a similar way for nitrogen, if you break this nitrogen, bond energy for nitrogen is 946. But delta H atomization is going to be the half of bond energy. So 946 divided by 2, this is going to be delta H atomization of this nitrogen. Now, third definition is ionization energy. This thing you have learned in atomic structure chapter. Ionization energy, as the name indicate, ionization. In this process, ionization will occur. How ionization can occur? Ionization occur by removing electron. How electrons they are being removed? For ionization is energy required. If there is energy required, this process is going to be always endothermic. Energy required to remove 1 mole of electron from the valence shell of 1 mole of gaseous atom. 1 mole of gaseous atom, that is known as enthalpy change of ionization energy or simple ionization energy. Atom must be in single gaseous form. For example, this is our X. It must be gas, and 1 electron is removed from this X, will form positive and 1 electron. It's known as first ionization energy, and keep in mind this is always endothermic. And for second ionization energy, we'll remove another electron from the X positive 1, that is known as X positive 2 and 1 electron. And for third ionization energy, there will be a positive 2, will remove another electron to make it X positive 3 and 1 electron. This is second ionization energy and third ionization energy. And what should be the trend between first, second, and third ionization energies? Third ionization energy is always more endothermic, then second and first ionization energy is going to be least endothermic. What's the reason behind in it? If you remove 1 electron from any atom, its attraction between nucleus and valence electron will increase because it's getting a positive charge. So when there is a positive charge, there will be more attraction between nucleus and valence electron. So when you're going to remove another electron from the valence shell of X positive ion, you need more energy. And similar case with X positive 3. X positive 2, that has more attraction than X positive 1. So when there is more attraction, you need more energy. So for in the successive ionization energies, this process is going to be more endothermic. And second last definition is for electron affinity. Electron affinity is opposite to ionization energy. In ionization, electron that is being removed from the valence shell, but in electron affinity, electron will be added into the valence shell of gaseous atom, that is known as electron affinity. So what is electron affinity? Enthalpy change. Enthalpy change when 1 mole of electron is added into the valence shell into the valence shell of gaseous, or into the valence shell of 1 mole of gaseous atom. 1 mole of gaseous atom, that is known as electron affinity. For example, this is X. It's a gas, and we are going to add 1 mole of electron into X. It's getting a negative charge. This thing is known as first electron affinity. And shorter term for this electron affinity is EA. This is first electron affinity. What is the first electron affinity? Enthalpy change. When 1 mole of electron is added into the valence shell of 1 mole of gaseous atom, it should be gaseous atom, to form X negative 1 ion. This is first electron affinity. First electron affinity is always exothermic because attraction is between the nucleus and valence electron that will increase. So this is a reason this is all first electron affinity is always exothermic. But for second electron affinity, what is second electron affinity is 1 negative charge, 1 enthalpy change when 1 mole of electron is added into the valence shell of gaseous. 1 negative ion will add 1 mole of electron to make it X negative 2. And this second electron affinity is always endothermic. What's the reason for this? There is a negative charge on X negative 1. And in the negative charge, you are adding more negative charge. So there will be a repulsion. This is X negative, will add one more electron into it, or 1 more negative charge into the negative charge. So there will be a repulsion. To minimize that repulsion, this energy is required. This is the reason second and third electron affinity is always endothermic. And first electron affinity is always exothermic. Second, third, they are endothermic. So electron affinity can be endo or exo collectively. Endothermic or exothermic, this is a way how we can differentiate between first, second, and third electron affinities. And what are the factors which can affect electron affinity? There are 2 factors which can affect electron affinities. Number 1 is effective nuclear charge. What was the symbol for effective nuclear charge? For effective nuclear charge, symbol was Z effective. This is capital Z and effective. This was effective nuclear charge. This Z effective is directly proportional to the electron affinity. These are the factors which are affecting first ionization energy. You should keep in mind. And if you see for electron affinities or Z effective increases, for example, starting from nitrogen, then starting from carbon, nitrogen, oxygen, and fluorine. Effective nuclear charge for carbon is positive 4, nitrogen positive 5, positive 6, and positive 7. These are the effective nuclear charges. Now you can see as you move across a period for second period, the effective nuclear charge increases. Due to increase in effective nuclear charge, atomic radius will increase. Now, can you tell me if atomic radius decreases, if there is smaller atom, then it will have a greater attraction for the electrons. If the atomic radius is very small, that will have greater attraction for the electron which are going to be gained or which are going to be added into the valence shell. You have learned in the chemical properties of halogens down the group chemical properties or chemical reactivity of group 7 or 17 elements decreases. What's the reason behind in it? Fluorine, that has a smaller ionic radius, smaller atomic radius. When there is smaller atomic radius, it can easily gain electron. But chlorine is going to be less reactive than fluorine. The reason behind is chlorine has a bigger atomic radius. If there is a bigger atomic radius, that will be difficult for chlorine to gain electron as compared to fluorine. The same thing happens here. This carbon has a bigger radius than fluorine. Fluorine has a smaller atomic radius. So fluorine can gain electron very easily. When it can gain electron more easily, so electron affinity becomes more exothermic. And second factor is going to be atomic radius. Number 1 was effective nuclear charge, and second is atomic radius or shielding effect. Now for shielding effect, if number of shells they are increasing, shielding effect will increase. When there will be a more shielding effect or atomic radius will be more, then it is going to affect electron affinity inversely. So shielding effect is inversely proportional to the electron affinity. If you see for this fluorine, chlorine, bromine, iodine, and astatine, down the group the shielding effect increases. When there is more shielding effect down the group, the radius will be bigger. When the radius is bigger, that will be very difficult for an atom to gain electron. So shielding effect is inversely proportional to the electron affinities. These are the factors which can affect electron affinities. Now last definition, that is lattice energy. There's a new definition for you. Lattice energy. Lattice, it's a term which is used for usually for ionic lattice, ionic compounds. And in ionic compounds there is one positive and the second is negative ion. That is known as ionic bond. So lattice energy is, and all the ionic compounds they exist in lattice form. So how we can define this lattice energy? Lattice energy is energy released when 1 mole of ionic lattice, when 1 mole of ionic lattice is formed from its gaseous ion. This is a definition you should keep in mind. Lattice energy is energy released when 1 mole of ionic lattice is formed from its gaseous ion under standard state condition. The thing you should notice that is, for ionic lattice is formed, this should be 1 mole. On the product side, how many moles there should be? On the product side, there should be 1 mole. You cannot change the number of moles on the product side. The only thing you can do with the reactants, you can change mole of reactant. See this example for lattice energy, NaCl solid. Identify the ions which are present in the sodium chloride. Sodium, it's a positive charge. Chloride, there is a negative charge. We'll write Na. This positive, it must be in gaseous form, and Cl1 negative, it must be in gaseous form. They will react together to form NaCl. This is the lattice energy for NaCl. And can you write for magnesium bromide, lattice energy for magnesium bromide, MgBr2? That is going to be for magnesium and 2 positive charge and 2 Br negative. They must be in gaseous form. They will react together to form MgBr2. This was about lattice energy. Again, there are 2 factors which affect lattice energy. We'll discuss after learning Born-Haber cycle.